In the last two videos, we applied valence bond theory to ethane and ethyne. So logically, in this video, we're applying it to ethyne. Ethyne is the third of the two carbon atom hydrocarbons. It has a triple bond between the two carbon atoms, and therefore each carbon atom is only attached to one hydrogen atom, bringing it up to a complete octet. This means that each carbon atom therefore has two electron groups attached. It's attached to a carbon and it's attached to a hydrogen, and that means that it is linear in shape. And since each carbon atom is linear, that means that each carbon atom has to be sp hybridized in order for us to be able to create the appropriate bond angles. So I'll start off by redrawing my molecule, making sure I have lots of space to draw on it. Each of my two carbon-hydrogen bonds is a single bond and therefore a sigma bond, and it's made by combination of an sp hybrid orbital on the carbon atom and a 1s orbital on the hydrogen atom. As I mentioned before, double and triple bonds all start with a sigma bond, but then they also have the other bonds as pi bonds, because the other bonds are formed from the combination of the p orbitals left over after we make the required hybrid atomic orbitals. So our sigma bond is going to be between the sp orbital on each of the two carbon atoms, and then our pi bonds are going to be between two p orbitals on each of the two carbon atoms. And I think it is important to communicate your understanding that the 2px mixes with a 2px and the 2py mixes with a 2py. You can't make a pi bond by combining a px with a py. They point in different directions. And that's pretty much it for putting together a valence bond description of ethyne. It's a triple bond. You can't rotate around it, but even if you did, you wouldn't notice, because the whole thing's linear.